Checkout tracking by the NPD Group brings you a receipt collecting system that gathers data anonymously through technology we created, providing your businesses with answers.
Yeah, thanks for the introduction. Thank you for everybody. I know it's been a long day, and thanks for sticking around for the bitter end of the presentations. So I'm Ehren, co-founder of a business called Wearable Haptics. We are a Seattle-based startup commercializing wearable haptic interfaces for all sorts of different applications. The one that we're most interested in right now and focusing most of our effort on is in gaming. When we look at virtual reality and we look at all the head-mounted displays that are coming onto the market next year, I think what's immediately apparent is it really is all about your eyes. To a lesser extent, it's about your ears. But really the heart of virtual reality as we currently conceive of it is a visual experience. Putting on a head-mounted display gives you this immersive, kind of spectacular, beautiful visual experience. And your sense of touch is kind of totally ignored. And so one of the things that we're excited about is the use of your sense of touch as an additional channel for communication. And one of the inspirations for the idea was, for those of you who are old enough to remember the early days of Spider-Man, Spider-Man had what is called the Spidey Sense, such that if somebody was sneaking up behind him, he would get a little tingling in the back of his neck. And it's a sense that kind of we all wish we had, but it sadly don't. But you can simulate it within the virtual environment. And so if you look at even just the form factor for the head-mounted displays that are coming onto the market, it's just really overwhelmingly about eyes, and as I said, to a little bit lesser extent about ears. But one of the nice things about using tactile communication as an additional channel to give somebody information is it doesn't further burden your audio or visual circuitry. And so the argument is that it's impossible to actually give somebody more information without it being a distraction. Tactile feedback is absolutely compatible with with head-mounted displays, with other forms of virtual reality. You can use it standalone or absolutely in concert with a head-mounted display. We kind of view that as the next step in virtual reality once head-mounted displays become a consumer kind of mass market reality. And then probably most interestingly for all of us, it creates a really new dimension for developers to play with, because you can, using your sense of touch, you can give somebody a sense that they don't have in real life. You can give them a intuitive situational awareness of things that are going on around them. And the possibilities for that in terms of creating a really immersive virtual experience are pretty phenomenal. So most people, when they think of haptics, it's about simulation. It's about simulating what you would feel in the real world. Whether it's the steering wheel that resists your motion like the steering wheel of a real car would do, or force feedback in a game controller that vibrates like a weapon would vibrate. Most of the attention in tactile feedback has been in simulation. But one of the main things we're excited about and interested in is using tactile feedback to actually deliver information to the user. So what would that look like, using tactile feedback as communication rather than just simulation? One of the fundamental features that we're looking at is giving you a sense of range and bearing to targets. So if you're in a first-person shooter, you can create almost a sixth sense of the player of, oh, there's a teammate over there, there's an enemy over here, it's at 7 o'clock behind my head, maybe 30 feet away. And you can actually get that sort of resolution using tactile feedback. The way that we do it is with a cap that's embedded with haptic actuators. And then we use that to deliver the directional information as well as encode the range of what you're trying to track. It's also very interesting to use for identification friend or foe, for telling enemies versus friends. If you look at something in the game, you could conceivably be able to feel, whether that's a teammate or an enemy. In-game navigation is another feature we've been experimenting with, which is instead of having a map that you're constantly looking at to navigate within the game, you can actually feel where your waypoint is, or you feel where you're supposed to go, and it's able, you're able to deliver that information to somebody without it being distracting. In multiplayer environments, you can create a rally point, and all of a sudden, all of your teammates can feel where they're supposed to go, and they get this sensation, for example, in their head, and you turn, and then you move forward until you actually get to the intended location. Threat warnings. So, we have encoded health warnings in tactile feedback. So, as your health decreases, you can feel, like, for example, a pulsing with increasing urgency. You don't have to look at your health meter. You don't have to think about anything. It's this intuitive kind of reaction that we have to tactile warnings with just a little bit of training and learning. And then hit detection. So, you can detect very quickly. You can indicate to somebody through their sense of touch, where shots are coming from, for example. And it's something that's typically hard to do in a first-person shooter game. Usually you see the whole left side of the screen light up or the right-hand side of the screen light up, which could be anywhere in a 180-degree arc. You don't know how high it's coming. And so using haptic feedback, you can get a much higher degree of resolution. You can react much more quickly, all of which create a more immersive, more fun experience for your user. So the ultimate vision that we have is that tactile feedback will become one of the central ways that people interact with machines. Really, right now, it is all about your eyes and, to a lesser extent, your ears. But because of the rise of mobile devices, haptic feedback, hardware has become increasingly cheap, increasingly sophisticated, and it opens up a lot of interesting possibilities for us to play with. Most kind of centrally, you can use haptic feedback to increase situational awareness. This works both in the real world and in the virtual world. You can, give somebody almost a sixth sense of what stuff is going on around them, what stuff's going on behind their head. One experience that probably most of you have had with putting on a head-mounted display is that even though you're in this three-dimensional virtual environment, this really compelling visual experience, you still have the impression that you're looking down a straw. And you really don't know if something's going on down here until you actually look at it. And one of the interesting challenges with the head-mounted displays is how do you tell somebody what they should be looking at? And using tactile feedback is one very non-distracting, kind of subtle way of doing so. As I mentioned before, if you're not loading somebody's visual or auditory circuitry, you're able to deliver that person more information without it being distracting. And over time, we expect almost like a haptic language to develop, whereby the words in this language are the buzz or tap, wobble, little puffs of air. And you can encode all sorts of interesting information using these sensations. We expect as haptics become more mainstream and as people start using them more for communication purposes rather than just simulation, that certain conventions will arise, just as they have for, everybody expects the mouse pointer to look a certain way. Everybody expects, okay, this is what, your health meter looks like, or your shield indicator. These are the controls to switch a weapon. And in the same way, we expect certain conventions to arise with haptic feedback as it becomes more mainstream. That will make it easy for developers to add haptic effects to their games, and consumers will be able to then adopt those haptic effects and use in a very low friction way. The genres that we're primarily looking at, I mean, first-person shooters is what I've been talking about probably most. Survival horror is a very compelling case for haptic feedback, because you can give somebody playing a game like Amnesia, if you remember from a couple years ago, a really, really scary experience. You can give somebody a real spine tingle, or a sense of kind of impending doom. Like one of the earlier speakers mentioned, you can create all sorts of suspenseful emotions, using solely your sense of touch. And then simulation for, in the same way that most of you probably have blind spot monitoring in your car. So if you turn on your turn signal and there's a car in your blind spot, a little light comes up and a little beep, goes off. And you're like, oh, there's a light going on and a beep, that's sounding. What's that mean? Oh, there's a car in my blind spot. Instead, using haptic feedback, you would be able to continuously perceive where other cars are around you, such that it wouldn't be that same level of distraction. And the same thing works in vehicle simulation games. So in terms of how would a developer actually implement haptic feedback in a game? We're making what we hope will become very general use devices that you can plug into any number of mobile devices, PCs, consoles, and they will support kind of the standardized set of the standardized haptic language. Anywhere from if you want to give somebody haptic radar, all you do is you pass a list of targets that you want tracked, and then your user can actually feel where those targets are. So I'm going to close with a couple of predictions, and then we'll get to the discussion. That once, assuming that the head-mounted displays, fulfill at least part, hopefully most of the expectations over the next year or two, it's already very competitive, and it's going to continue to be competitive. And the companies are going to be looking for ways to differentiate their products, and haptics is kind of the next obvious way that you could go, because we're tapping into a sense that is currently being kind of ignored. Consumers, I believe, over the next year are going to be a little frustrated with how pricey the technology actually is, and how much of a commitment you have to make, especially at an early stage, to get into virtual reality. Haptics is much cheaper. The technological challenges are fewer. Haptics, you typically don't run into issues with latency. You don't have to run something at 90 frames per second. And you don't typically have problems with motion sickness. And so in terms of the actual technical implementation, it's more straightforward with haptics. I think doing it well, just in the same sense that doing visual-based virtual reality well is non-trivial, but from a technical standpoint, it should be more straightforward. And this goes back to a presentation just in the last hour. I think what is becoming widely known now is you can't take an existing game and simply port it to Oculus or to a head-mounted display and expect it to be a really good experience for the user. In a lot of cases, you have to rethink sometimes fundamental elements of the UI design. And this is less the case with haptics. We expect it should be quite a bit easier for developers to implement, even port, games, add haptic effects to games without really having to go through the same level of, wow, we really need to rethink how we can, design our user interface without using text. This is what I alluded to earlier, that I think these trends will become clear over the next year or two, and increasingly we're going to see head-mounted displays starting to integrate haptics into their products. None of the ones that are mainstream that I know of right now do so, but I very much expect that to change. And as I said before, over time we're going to see the emergence of a standardized way of doing things when it comes to haptics, a standardized way of representing, oh, there's something over there and it's that far away, or this is a teammate versus an enemy. that developers it'll make it easier for developers because you'll be able to assume that your audience knows a certain amount of this haptic language, and then for the audience it'll be easier to pick up a haptic feedback device, put it on, and use a game that supports it and understand it right off the bat and have it be intuitive very quickly. So that's it for the presentation section. I'm happy to take any questions, or get hopefully an interesting discussion going.
Your head-mounted one you showed there, for the head-mounted one that you showed there, how many motors would be?
Currently, we use 13. 13. Yeah, and we've experimented with greater numbers, and we've experimented with lesser numbers, and 13 is the current the current design. I can get into the details of that a little bit later if you're interested.
Is the power consumption?
It runs off USB.
Gotcha.
Yeah, in the current version is wired, but we expect the next version will be actually wireless.
Thanks.
Mm-hmm.
Anybody else? Anybody else? You? No? All right.
Okay.
Let's
you.
thank Ehren.